Trig graph equations, algebra 2 trigonometry regions. So the previous slide had this, previous lecture had this slide, so I'm not going to spend too much talking about it. We discussed how amplitude was the height of the graph and its absolute value, because even if we have a negative there, it does eventually go up. But it is important to know that if this is negative, the graph will go down first instead of up first for sine. Well, no, I mean cosine goes down first, so cosine would be upside down, but it basically is a reflection of the x-axis if that is negative. So we want to watch out for that because that's going to help us. Frequency is the number of cycles between 0 and 2 pi, 0 and 180. Zero and 2 pi, 0 and 360, sorry. I think I said 180 before. So number of cycles between 0 and 360, 0 and 2 pi. And that number is here. Period is where the first cycle ends. And this is probably the most important, especially for the hard ones, because that's what you're going to have to use. So it's where the first cycle ends, where the first cycle ends. And we get that from a formula of 2 pi divided by b, and b being the frequency. So 2 pi divided by that number tells us where the first wave ends. Cycles, waves, I'm just using cycles here, but it's where the first wave ends, where the first cycle ends, okay? All right, so using these three concepts, that's what's going to help us figure out what the equation is. So what these problems are is they look like this. You're given a trig graph picture, and what we're tasked with is determining the equation. Now, we will definitely use our calculator to help us here, because ultimately we could kind of guess and check these and see if it matches. But let's first try to do it without that. Let's go over a couple of things. First of all, can you figure out the A amplitude? So amplitude is the height of the graph. Now, notice that, well, I guess really where you should start is it sine or cosine? And the fact that it's not coming from the origin, right, that's what sine looks like, this is clearly a cosine graph. And so that right there, I think, is probably how you should begin. Is it sine or cosine? Because that will definitely rule out some of your choices sometimes. So it is cosine. What is the amplitude? How high does it go? Well, cosine starts actually at the amplitude, so it is 2. And it's a positive 2. If it were negative 2, then it would be upside down like that, but it is a positive 2. Then you could do frequency. How many cycles of cosine do we have in a 0 to 2 pi range? And what I see here is simply 1 cycle of cosine in a 0 to 2 pi range. So our frequency is simply 1. You don't need period here because this is enough. It's 2 cosine 1. So I'm looking for amplitude of 2, A is 2, frequency of 1, and we're looking for cosine, so it is clearly choice B. Now, where these pictures will get complex is when they don't show us the window to 2 pi. Like if they cut the window off at pi, like right here, sometimes you're thinking, oh, they're only showing me half a cycle. Well, that's true, but you always got to picture it in a 0 to 2 pi range. And we'll see that in a couple of examples. So make sure whenever you're doing frequency, it's from 0 to 2 pi. It's from 0 to 360. And if they're not showing you 0 to 360, you still need to think about that when you're determining frequency. Period is, again, where the first cycle ends. That'd be 2 pi divided by b, which is 1, which is 2 pi over 1 is simply 2 pi. And this is where the first cycle ends, is at 2 pi. But the easy examples don't require you to use period. The complex ones do. Now, of course, we could type this into our calculator. I'll type it in real quick. If I type in y equals 2 cosine x, and start off with zoom 7 for trig, zoom 7, but then we're going to adjust our window here. Now this is good, but I want my window to match this window. So my x value goes from 0 to 2 pi, which I know really means 0 to 360. Now I actually can tell that my calculator is on the wrong mode, so I'm going to put my mode on degrees. Now do I have to put it on degrees? No, I could keep it on radians and type 2 pi, but I think most of you would probably prefer doing degrees. So I'll go from 0 to 360. Remember, 2 pi is 360, so that's my x value. I'm going to set it to match this 0 to 360. My y values could be negative 2 to 2 if I want to do that, or I could keep it a little bit larger, but let's set it so it's exactly here. So we're going negative 2, positive 2. All right, and let's see what we get. Does it match the picture? Yes, it does. So you can compare graphs. Now, again, this one maybe looks like it's a little bit, uh, a little stretched this way, or so it's not always going to match perfectly, but you could get a good idea if it is right. Do you have the same amount of cycles and so on? So we'll be graphing these to check our work. Number 3. All right, first of all, is it sine or cosine? And it clearly is sine because it starts at the origin. Cosine starts at the amplitude. So it's definitely sine, so we're down to one of these 3. What is the amplitude? How high does the graph go? That graph goes as high as 1/2. So A equals 1/2, so that's in front of the graph, not 2. So I'm down to one of these. So then the question becomes, what is B? What is our frequency? How many cycles we have? And this is where students get tricked. This is a very common trap when it comes to trig graph questions. Remember, for B, it's in a 0 to 2 pi range. But the window they're showing us here is from 0 to 1 pi, not 2 pi. So although I only see one complete cycle of sine here, remember this is one cycle of sine, my frequency isn't 1, my frequency is going to be 2. Because if I have one cycle at 1 pi, I'm going to have 2 cycles by the time I get to 2 pi. And that's why my frequency would be 2. And that's why it's 2x, and so the answer is C. So if they ever give you a window that's short of 2 pi, you do need to either extend it yourself or just make that note that this is not the whole view of what you need. Could you do period? Your period is pi. Our first cycle is ending right here. So if the period is pi, you could do 2 pi over, over what gives me a period of pi. And so this clearly has to be a 2, because 2 pi over 2 is pi. So your frequency must be 2, which again works out there. But I think just really making that mental note, if they give you a picture that only goes to pi or pi over 2, that's really important for determining your frequency. And then lastly, we're going to type it in. We're going to check our answer. So we'll type in y equals 1/2 sine 2x. But I need to adjust my window. My window, I want to match this picture. So my last problem was 0 to 360, but this one's going to go 0 to 180. Pi is 180. So I want 0 to 180. And my y-axis is only going as high as 1 to -1, so I'll change that to -1 to +1. And then let's see if I get this picture of one complete cycle of sine, and I absolutely do. So, that's the last thing you could do is check that, because if I thought it was this, I'm not going to get a picture that matches. So that's definitely a useful feature there. Let's try one more. What is the equation represented by the accompanying graph? Okay, so it's going through the origin, so that means it's sine. They all have sine. What is my amplitude? Now, they're only showing me that the graph goes down. First of all, sine usually looks like that. So why would it be upside down? Well, that is when you have a negative a value. Our amplitude, since this goes down to -2, if the graph were to continue, it would go up to +2. But the fact that I'm opening down first means that a equals -2. So when you see the graph going down first for sine as opposed to like that, that's telling you got a negative a value. Our amplitude would be +2, but our a value is -2. And so that is actually enough to answer the question right here, because this is the only one with an a value of -2. Well, let's just talk about the rest. What would our frequency be in a 0 to 2 pi window? Well, do they give me 0 to 2 pi? Here's 0, here's 2 pi, so yes, they do. And how much of the sine curve do I have? Well, the curve has a complete like that, or if it's upside down, it would be like that. But they're only showing me half of the sine curve. So that's why my frequency is 1/2 right there. And so again, that confirms that right there. Period is actually going to end at 4 pi. But again, I feel like that's making it more complex. You don't only start using that period if you really can't figure it out with amplitude and frequency. A lot of times that's going to be enough. And I think that's probably where we'll stop this video today. We're gonna see a couple other styles of trig graphs like the reciprocal functions and tangent. But we're gonna do that stuff in class because it's really just all you gotta be able to do is recognize what they look like. So we'll take a look at those also in class. Obviously, you need your calculator for this stuff. Well, actually, you don't need it, but it definitely helps quite a bit. Lastly, let me just type this in and check my answer here. So -2 sine 1/2 x, and my window needs to be set back from 0 to 360. 0 to 360 is 0 to 2 pi, and y minimum is -2 to 2. And I should get just a matching picture like that. So that's it. We'll play more with this tomorrow. See ya. See ya.